Here we'll talk about the equilibrium of forces. Equilibrium is in the state of the rest of a body, that is, the body does not move or also does not rotate about any point under the action of forces. For a rigid body in static equilibrium, the external forces and moments are balanced and will import no translational rotational motion of the body. However, it could be translating or rotating at a constant velocity. So let us see about this constant velocity, how it's getting rotated, and then what is the equilibrium of forces or equilibrium and the rest of the body, and all we can see it in this one. Mainly these external forces and movements are balanced and it will not have any translational rotational motion. That's how it's being defined in this and when object is in equilibrium under the action of a system of forces, the following conditions are satisfied. So there are two conditions that has to satisfy. One is force equilibrium and one is moment equilibrium, that we will see it here. The algebraic sum of the components of the forces in any direction must be equal to 0. Algebraic sum of the moments of forces about any point must be equal to 0. These are the things we need to see about this one. And then so sum of components of force and sum of moments of forces, both conditions has to satisfy. Static equilibrium is the state in which the sum of forces and moments on each particle of the body is in balanced. Examples of free body diagrams, you see the different systems here. Wherever the contact point is there, it's perpendicular to the surface, there are forces. W is the weight force and N1 N2 is the normal reaction forces. So it's a 3-point, it's a concurrent forces. Then at the W is acting at the COG, and then these two forces also it's passing through the center. That's why it becomes in equilibrium. There is no unbalanced force that causes the rotation or anything. So yeah, these are the other examples, and here we can see these examples. When the rough surface is there will be a development of friction forces in the horizontal direction. When it's a smooth force, it will produce only the normal reaction. It will not produce any frictional or shear kind of force. That's given here, examples, moments as well as forces.